Welcome to this deep dive into the fascinating world of neural networks. Today, we'll uncover how these remarkable systems process and interpret data, powering technologies that shape our daily lives. Neural networks are at the heart of artificial intelligence. Modeled after the human brain, they are designed to recognize patterns, solve problems, and make decisions. But how exactly do they work? At the core of a neural network is a simple but powerful concept: layers of interconnected nodes, also called neurons. These neurons work together to process information step by step. A neural network consists of three main layers: the input layer, which receives raw data, the hidden layers, which process the data, and the output layer, which delivers the result. Each neuron performs a mathematical operation, passing the result to the next layer. Let's take an example. Imagine a neural network trained to recognize images of cats. The input layer receives pixel data from an image. The hidden layers analyze this data, breaking it down into features like edges, shapes, and patterns. By the time the data reaches the output layer, the network determines whether the image contains a cat. The magic lies in the connections between neurons. Each connection has a weight, a numerical value that determines the importance of one neuron's output to the next. During training, these weights are adjusted to minimize errors. But how do neural networks learn? They use a process called backpropagation. Here's how it works. First, the network makes a prediction. Then, it compares the prediction to the actual result, calculating the error. The error is sent backward through the network, adjusting the weights to improve accuracy. This process is repeated thousands, even millions, of times, allowing the network to learn from its mistakes. Did you know that neural networks are the foundation of technologies like facial recognition and language translation? For example, Google Translate uses neural networks to process and interpret text in over 100 languages. Deep neural networks, which have many hidden layers, are particularly powerful. They enable self-driving cars to interpret their surroundings and make real-time decisions. One key breakthrough in neural networks is convolutional neural networks, or CNNs. These are specialized for image recognition, breaking down images into grids and focusing on patterns like edges and textures. Another type is recurrent neural networks, or RNNs, which excel at processing sequential data. They are used in applications like speech recognition and predictive text. Consider this: by 2024, over 80% of data science projects are expected to involve neural networks in some form. Their impact is massive, shaping industries from healthcare to entertainment. For instance, in healthcare, neural networks analyze medical images to detect diseases like cancer with remarkable accuracy. In entertainment, platforms like Netflix use them to recommend shows based on your viewing history. Training neural networks requires immense computational power. That's where GPUs and specialized chips like Google's TPUs come into play. These hardware advancements enable faster training and larger models. However, neural networks are not without challenges. One major issue is their black box nature. It's often difficult to understand how a network arrives at its decisions, raising concerns about transparency and trust. Another challenge is data bias. If a network is trained on biased data, its predictions will reflect those biases. This highlights the importance of diverse and representative datasets. Despite these challenges, the potential of neural networks is limitless. Emerging fields like neural architecture search aim to design better networks automatically. Moreover, advancements in quantum computing could revolutionize neural networks, enabling them to process complex data even faster. To sum up, neural networks are transforming how machines interpret data, opening doors to innovations we once thought impossible. From powering virtual assistants to diagnosing diseases, their influence is everywhere. Thank you for joining us on this journey into the world of neural networks. Don't forget to like, subscribe, and share this video to stay updated on groundbreaking AI technologies. Until next time, keep exploring the science behind the algorithms.